Okay, so I'm going to look more at some packed instructions. So we'll start with PABS, which has this BW, D, and Q suffix. The Q suffix only exists in EVEX encodings, and the EVEX encodings for D and Q also support the memory broadcasts. So we'll just go over to the encoding or the encoder ASM tests, and we'll start with PAND. PABS, B. So we'll skip this MMX one, but we'll just basically do RM for B here. Then we'll move up to the VEX one. It looks like all of them do the operand encoding as RM. So we'll just copy that for each of them. So we do xmem0 with xmem1. Then a memory access. We'll copy this for VEX. And we'll also copy it for EVEX. Let's just do an op mask to force the EVEX encoding. So because this one's B, it doesn't support the memory broadcasts at all. And for VEX, we need YMM. And then for EVEX, we can do YMM and ZMM. So let's just check that that's okay. Seems like it's all fine. Okay, so we'll copy this one for W. And we'll copy it for D as well. But D in the EVEX versions supports broadcast. So this will be 1 to 4. This will be 1 to 8, and this will be 1 to 16. Then we can go up to Q, but Q only exists from EVEX encodings. So we'll get rid of the legacy and VEX encodings here and then change these ones to Q. Because Q has doubled the element size, the broadcast needs to halve the number of lanes. Okay. So that's ABS. Next, we'll move on to PAND. So PAND has, we've got just PAND in the legacy. Then once we go up to EVEX, we get these suffixes for D and Q here. So we'll do PAND with, we'll ignore MMX, so we'll just do RM. So this is xmem0, xmem1. Memory access, and then we've got VPAND. So this is basically now onto 3 operands. So we'll add xmem2 and xmem1 here. And then of course this supports to YMM as well. Let me just check the apps one again, just make sure. Yeah, okay, it was just 2 operands. So PAND is 2 operands for legacy and 3 operands for VEX and EVEX. So VEX is just XMM and YMM. And then as soon as we get up to EVEX, we get the op masks. And we have to put a suffix on the end, so this will be D. So for D we get the op masks, we also get broadcast. So this would be 1 to 4, this would be 1 to 8. And then we can make a copy of those for ZMM. Then we can make a copy of all of these for the Q suffix. And because the element width has doubled, the lanes for broadcast needs to halve as well. This one goes to 4, this one should go to 16 up here. This one goes to 8. That all looks okay. Then we also want AND N. So AND N here is the same. So we'll just copy these and change them to AND N. Then we'll do POR. So POR is here. This one is also the same. It has the D and Q suffixes for EVEX. So this is POR. And then we'll have XOR, which I assume is just more of the same as well. So we'll just do this. And then finally, there's a PTEST here. So PTEST only has a few forms. We've got PTEST for legacy, which is RM. And then we've got the VEX versions, which just support up to YMM. So we'll do V, and then we'll change this one to YMM. Okay, that all looks okay. So if we just create the test notation for this stuff. That looks like it should be fine. Okay, let's just reassemble this for the listing. And then we just need to take all of these mnemonics. So we go down to PTEST. Let's just put these below these other ones here. Or maybe we'll put them below div. So we just need to deduplicate these. We'll separate them by their suffix. This is, and maybe we'll keep these ones together. Okay. Right, let's just take these down to the name table. And create a name string for all of them. Then we can just take this over to the forms table. And create some empty form tables for them. So go test should fail immediately as usual. So we'll start with PABS. So PABS here, we're going to match on XMM. We've got a prefix of 66, map is 38, and the opcode is 1C. So let's just match on the width is X word. Op-n for this is op-n-rm. Op1 is vec, op2 is vec or memory. The prefix for this is 66. Map is 0f38, I think it was. And then the opcode is 1C. I think I've got a syntax error in here. There it is. Okay. Okay, so that's PABS legacy for B. Then for so for W it goes up to 1D and then 1E for the D version. But the D version here, yeah, okay. 1E for the D version that's not MMX. And then it looks like it stays the same for the others. The W bits is used for the Q ones in EVEX. Okay. All right, so let's just look at this EVEX one. So we'll go family VEX. In this case, we're going up to Y word. And then we also want EVEX, which will go up to Z word. So it's got PABSB. That's because we need to accept op mask and zeroing. And now it's on to W, so I can just copy this one. Change this to W, and then change this to D. Then for the D version, we'll change this to E. And then for the Q version, I'm assuming this is going to be E. Oh, it's going to be F. Okay. So for this one, we don't have legacy, but we do have, was it just EVEX? Yeah, just EVEX for this one. So we'll just remove that. This one goes up to F. And then for this one, I think W was set. Okay, so PABSD needs to accept broadcast on memory. And the same goes for Q as well. So this needs to accept broadcast. Okay, so now we're on to PAND. So for PAND, we're going to skip MMX. So this one is basically the same as PABSB here. But we have the secondary opcode map with DB as the opcode. So now it's on to VP AND. So VP AND here is for VEX only. So this needs to be family VEX. VEX needs to go up to Y word. And in this case, the operand encoding is RVM. So this is RVM, op1 is VEC, op2 is VEC, and then op3 is VEC or memory. Yep, that looks correct. So now we're on to the EVEX ones. So for D here, this is family EVEX. It's going to support up to Z word. And it looks like we need to add in the op masks and broadcast. So op1 here is op mask and zeroing, and then op3 here should also accept a broadcast. And then it moves on to Q, which is DB, but W1 is set. Okay, so now it's on to AND N. So I assume that the rest of these, with the exception of test, are going to be more of the same. So we'll just take P AND, rename it to AND Q, rename this one to POR, and this one to PXOR. So for AND N, we've got DF as the opcode for all of these. POR is EB. PXOR is EF. And then we just need to go and fill in PTEST here. So we'll just take this PAND one, put this into PTEST. So we're matching on X word. We've still got RM, we've still got 6.6. This is now map 3.8, and the opcode is 1.7. Then for PTEST, the operand encoding is the same for the VEX version. But we can support up to Y word. So we need to change family here into VEX. Other than that, it looks like it's the same. Okay, so that was some more packed sort of like bitwise things and some absolute stuff. So